Today we are going to have new lecture. We are going to talk about distance measurements. We know that in surveying we are going to make measurements, and the most fundamental measurement is the measurement of distance. So today we are going to discuss the distance measurements. So in this lecture we are going to talk about the types of distance. We have three basic types of distances. And also we are going to talk about how to measure these distances. We have a measurement method like the pacing, like the odometer, like the taping, and like the electronic distance measurement. In this lecture, I'm going to walk you through each and every one of them. So first, we need to talk about the types of distance. So distance in surveying is regarded as the most fundamental of all surveying observations. Surveying, we have measurement, we have observation. So the most fundamental one is the distance. Measuring distance is the most fundamental measurement or observation in surveying. And we can categorize the distance into slope distance, horizontal distance, and vertical distance. So for example, if I have station A and station B. So if I'm going to measure here, like you can see here, we have slope. The ground is not leveled between station A and station B. We have a slope here. So if you are going to measure this distance here with the slope, then we call this slope distance. If you are going to measure this distance from here to here, horizontal, we call this horizontal distance. So in case of horizontal distance, we are going to ignore the slope. And if you are going to measure this distance from here to here or from here to here, we call this vertical distance. What's really important in surveying is horizontal distance. What we are going to measure in the field is horizontal distance. So we need to differentiate between the types of distance. We have horizontal distance, we have slope distance, and we have vertical distance. If the level of point A is the same as the level of the point B, then the slope distance is going to be the same as the horizontal distance. In surveying, the usual required distance is horizontal distances. In the field, when you get in the field, we are going to measure the horizontal distances. We have relation between the slope distance and the horizontal distance and the angle of the slope. So we are going to say that the angle here of the slope is alpha, and L represent the slope distance, and H represent the horizontal distance, and D represent the vertical distance. We can say that H, the horizontal distance, equals the slope distance times cosine alpha. So here we use simple mathematics in order to get relation between the horizontal distance and the slope distance. Similarly, you can find relation between the horizontal distance and the vertical distance, or between the slope distance and the vertical distance, as long as you know this angle here. So we have a variety of methods for the distance measurement. We have the pacing, we have the odometer, we have the taping, we have the electronic distance measurement, we have the satellite system, and also we have others type. Those are the main types in order to measure distances. The pacing and the odometer considered to be approximate methods. They are not accurate, but they are going to help you a lot to get approximate measurements. So I'm gonna walk you through each and every one of these method. First, we're gonna start with the pacing. So what does mean by pacing? Pacing consists of counting the number of steps. So you are gonna walk over uh, required distance, and then you are gonna measure or count your steps or paces. We call this process or this method, we call it pacing. Okay, so you have a required distance. You are gonna go over that required distance and count your steps. But in order to use this method, first, the length of an individual pace must be determined first. First, we need to determine the pace length in order to use this method. And the best result of that method, it could be done by walking with natural steps. So it's very important as this process goes on, you need to walk naturally. Okay, that is going to increase the accuracy of that method. So why we use this method? It used when approximate result is required. You need just a rough result. So in this case, we can use that. Also, it's used for reconnaissance survey. Also, it can use for preparation of military plans and approximate check-in distances. So let's say that you get into a job site, okay? And someone says to you, this distance is 100 meters, and you look at it and it doesn't make sense for you. So you can quickly check that distance by walking. Okay, as you walk, you will be able to get an estimate for that distance. Also in military plants, you know that it's not easy to take the taping and or the tape to get the measurement. Sometimes you need to do this by just walking, right? So although pacing is imprecise, okay, it can be useful when checking the positions of property and construction layout marks. We know that this process or this method is imprecise, but useful to check the position of the property and the construction layout marks, okay, at the job site. And the method is going to vary with the uphill. If you have uphill or downhill, it's going to affect the accuracy and also your age. And we have low accuracy regarding this method. And the beauty about this method, no equipment is needed. The other method is the odometer or the wheel. So in this method, we are going to use this rotating wheel. So as this wheel rotate, is going to count the measurement. Okay, this is also approximate method. So an odometer converts the number of revolutions. So as it rotates, it is going to create revolutions. Okay, and also it's important to know the diameter and the circumference of the wheel in order to that device to convert the rotating into meters. So an odometer converts the number of revolution of a wheel of known circumference to a distance. Lengths measured by an odometer on a vehicle are suitable for some preliminary surveys in road location work. So this one for preliminary survey, it can be useful. But again, this process is approximate process or approximate method. Of course, it's more accurate than the pacing, but it's approximate method. Okay. So in case that you have route location work, like roads or railway, this method it could be useful for us. They also serve as rough checks on observations made by other methods. So you can check your work with the odometer. Let's say that you measure a certain distance with the tape. If you want to make sure your work is correct, you can check with the odometer. Now we are going to talk about the taping, which is the most important and the most common used method, the taping. So what does it mean by taping? In the taping method, we use the taping method in the linear measurement of horizontal distance between 2 points using a surveyor's tape. So in the taping process, we are going to use the tape in order to get the linear measurement of 2 points and its horizontal distance. We have different types and shapes for the tapes. The tapes come in a variety of length and materials. Okay, we have a meter with a maximum of 10 meters, 30 meters, 50 meters, and 100 meters. We have a variety of lengths, and also we have a variety of materials. This one could be made from steel, or it could be made from fiberglass or any other synthetic materials. So the taping is fairly quick, easy, and cheap, and hence is the most common form of distance measurement. The most common type to measure the horizontal distances is to use the taping method. So for example, we are going to use this tape. The 0 is here. From here to here represent 1 centimeter, or it could represent 10 millimeters. From here to here represent 2 centimeters, and so on. So if you are here, then you are going to say that you have 5.5 centimeter or 55 millimeter. If you are here, you have 10 centimeter or 0.1 meter. Okay, it's very important to know that the start is here. Okay, some students make mistakes. They start from here or something like that. The other side here, we use the inches and feet. Okay, here we use inches and feet, while here we are going to use the meter and centimeter and millimeter. So you have to be careful. Please look at the tape before starting measurement. We have accessories associated with the taping. It's not only the tape, but also we have other accessories associated with the taping method. We have the ringing pulse, we have the plum bob, we have the pick, we have the chaining pin, and of course the most important one, which is the tape. We're going to talk about each and every one of them. First, let's start with the tape. We have synthetic tapes and we have steel tapes. The synthetic tapes are lighter and more flexible, but we have a problem with the synthetic tapes. They are less accurate than the steel tapes because they can stretch easily. You can, when we get to the site, you will notice this difference. Okay. On the other hand, we have the steel tapes. Those are more accurate than the synthetic tapes, but the problem with them, they require extra care since they can easily break. So if you are going to use the steel tapes, they can easily break, and also they can cut your hands, small cuts. Okay, so you have to be careful using steel tapes. So matrix tapes have standard lengths of 10, 20, 30, 50, 60, and 100 meters. We have a variety of lengths. Here we have a picture for synthetic tape. This one is made from fiberglass. and here we have steel tape here. We have advantage and disadvantage associated with the synthetic tapes and steel tapes. We have the chaining pin or arrows. Okay, so arrows are made of tempered steel wire of a diameter of 4 millimeters. So the diameter of this pin is 4 millimeter. At the one end here we have a paint into a ring of a diameter of 50. So the diameter here is 50 millimeter, and the other end here is pointed. This end is sharp. The overall length, the length maybe from here to here, is 400 millimeter. So why we use the chaining pin? An arrow, this pin is going to be inserted on the ground after every chain measured on the ground. So after you measure a certain point, so you can put this pin, it could be inserted into the ground. Also, we have the ringing poles. So the ringing poles are 2 to 3 meters in length. We have two types. We have ringing poles of 2 meters and other one of 3 meters. They used for ringing some intermediate points on the survey line. So sometimes the required distance is more than the length of the tape. So in this case, you need to create intermediate points. I'm gonna explain this more in the next slides. But you need now, at that point, you need to understand that we use the ranging poles in order to create intermediate points to connect the first point with the last point, because the distance is more than the length of the tape. And they are painted with alternative bands, either to be black and white or red and white colors. And the length of the band is 20 centimeters. So this one 20, 20, and so on. So why we do that? We do that, these colors are used so that the road can be properly sighted in case of long distance or bad weather. So sometimes you make the measurement and the distance is very long, and sometimes you have a bad weather. So for you to properly see the location, we painted the ranging poles with alternative colors. Like I said here, we have two types. We have 3 meters, and this ranging poles, it can be folded, okay? Because the length 3 meters, it's difficult to carry 3 meters with you. So this one, it could be folded, okay? The 2 meters, it could be folded in 2 folds. You are gonna see this when we get to the side, okay? And the 3 meters, it could be folded into 3 folds, okay? So that we are gonna carry the ranging poles without any problem, because if you have 2 meters or 3 meters, it's difficult to get this with you in the car, right? So that is why this one, it could be folded. We're gonna see that in the lab. Also, we have the pick. The pick, it could be made either from timber or from steel, and we use this one to mark the position of stations. We have a certain station A, B, C, and so on. So in order to know the mark, it's better to use the pick. And the length is about 15 centimeters, the length of the pick. And we have the Plum bob. This one, it's important, and it's important to understand why we need Plum bob. So let's say that I have station A and station B. But as you can see here, we have slope here. And remember, we say that we measure horizontal distances. So I'm gonna lay down the tape at point A. So exactly, because this one is close to the ground, I can know the zero measurement here. Then I'm going to stretch the tape, and then I need to know the horizontal distance, right? So I'm here. So the point or the station B is down. So how I'm going to know exactly I'm standing under the station B? It's difficult to know that, right? So here comes the role of the plumb bob. You're going to use a plumb bob here. So you're gonna lay the plumb bob like that. And because of the gravity, this one is going to be perfectly vertical. So you will be able to tell this point is going to correspond to that point on the ground. So we use a plumb bob to transfer points on the ground. In case like this, when it's difficult to tell the corresponding point here, we can use the plumb bob. It can make our job easy. So it's used for fixing instrument exactly over the station. So here we can know exactly this point is corresponding to that point on the ground. Two cases which we are going to face in order to measure 2 points. The first case, when the length to be measured is less than that of the tape. So, for example, you need to measure the distance between point A and point B. Okay, and the length of the tape is 20 meters, and the distance is less than the length of the tape. In this case, I don't have any problem. I need at least a minimum 2 persons. I need to have backward tape person and forward tape person. Okay, one is going to locate at point A, and the other is going to be located at the point B. Then the tape is going to be laid down along the straight line between point A and point B. The backward tape person is going to hold the tape here at 0. If you have a pick here, so here we should have 0, and the forward tape person is going to take the reading here. Okay, so the first case, when the length to be measured is less than that of the tape. So the procedure is going to be very simple. Similarly, if the maximum length for the tape is 20 meter and this distance is 15.5, then we have the first case, which means that the distance is less than the distance of the maximum length of the tape. The second scenario, when the length of the line between 2 points exceeds that of the tape. So in the second scenario, in the second case, the distance is more than the length of the tape. So in this case, for example, I have point A and point B, then the tape, the length of the tape is less than the distance between A and B. So in this case, I need to have a form of alignment. I'm going to create intermediate points between A and B, but these points should be aligned with a straight line of A, B. Okay, that the rule for achieving that, and we call this ranging, and is achieved using ranging rods and marking arrows. So first I need to fix ranging rods at point A and point B. Then I'm going to create intermediate points, but the intermediate point should be aligned with the straight line A and B. I'm going to create another one here, and here it depends, of course, on the distance that you are going to measure. And another intermediate point, and finally the last intermediate point. So how we are going to direct the to make sure that these intermediate points are aligned with the straight line AB. So in this process, we are going to use ranging poles. First, we need to put one at the first point and at the last point. Okay. Then first, I'm going to create the first midpoint. Of course, we in this process, at least we need 2 persons. This one is the backward tape person, and this one is the forward tape person. Okay, so now we create the first intermediate point. Like you can see here, the back, the forward tape person is going to direct the forward tape person, so that this intermediate point is going to be aligned with a straight line A, B. So this one, the direction is coming from here, whether it's vocal or hand signal. Okay, he's going to use his voice or his hands in order to direct the forward tape person. Then we are going to go for another intermediate point here. Again, we are going to repeat the process. The backward tape person is going to direct the forward tape person, so that the intermediate point here is going to be aligned to the straight line AB. If it's not aligned, then you are going to have errors. You are going to have mistakes. Your measurement is not going to be correct. Okay. So the second scenario, the length of the tape is less than the total length. In this case, we need to create intermediate points, and these points should be aligned with a straight line AB. Also, in the taping, we have the plumbing process. In this process, sometimes when you are going to measure the horizontal distance, you are going to have a slope like this one. So we know that the distance should be horizontal distance. We usually measure horizontal distance. Sometimes this point is away from the point on the ground. So in order to transfer the reading from here to the ground, we are going to use the Plum bob. We are going to use the Plum bob in order to transfer the reading here to the ground. Okay. Also, we are going to use the plumbing in case you have a slope here. For example, if I'm going to lay the tape like that, of course here it should be horizontal. Then in order to transfer this point here to the ground, I'm going to use the Plum bob. Similarly, here in this case, since I have a slope, I'm going to use the Plum bob in order to transfer the reading from here to there. Here we have actual picture, we have a slope. So in order to transfer the reading from here to the point, I'm gonna use the Plum bob. Okay, so because we take the horizontal distance, so we use the Plum bob in order to transfer the point. Sometimes where you are gonna have a slope like that, and you need to measure the horizontal distance. In this case, you are gonna use the Plum bob at the both ends, at the first point and the last point. You are going to use the Plum bob because there is no other way around. I need the horizontal distance, and the horizontal distance is going to be away from the ground. So I need to use the Plum bob at this end and at that end. So again, we are going to talk about the sources of error in taping. We talked about this in general. We talked about the errors in surveying in general, but this time we need to talk about the errors in taping. We know that no measurements can be perfectly performed. Okay, all measurements must contain some errors, unless you are counting numbers. If you have been asked to count the number of peoples, for example, in this room, then the measurement is going to be perfect because you are counting numbers. But in case of measurements, no measurement can be performed perfectly. Okay, you are going to have some errors. So from where we are going to get these errors? We have three fundamental sources of error in taping. First, we have the instrumental errors. Sometimes the device itself is going to be defective. We are going to have defects in the equipment use. A problem with the has been existed from the manufacturing process. Okay, so I bought, for example, the tape from the company, and the tape was, or the tape had a defect from the factory. I have nothing to do with that. So in this case, a tape may differ in actual length from its nominal graduated length because of a defect in manufacture or a repair. Okay, so the actual length is different from the nominal graduated length. So sometimes you are going to have a problem because of the instrument itself, not from you. Also, we have natural errors. Sometimes you are going to take the measurements and the weather is not good. You are going to take the measurement and the weather is bad. For example, maybe you have a rise of temperature that is going to affect the tape itself. For example, if you use steel tape and when the temperature rise, the length of the steel tape is going to increase. And also, if the temperature is low, then the length of the tape is going to decrease. Okay. Also, if you are measuring and you have a strong wind, that is going to affect your measurement. Also, the weight of the tape itself, it could affect the measurement. So we have errors from natural problem like the rise and the fall of temperature, the wind, and the weight of the tape itself. Finally, we have the personal errors. These errors resulting in tape reading errors. So as a forward or and backward tape person, you made a mistake in reading the tape itself. So we call this personal errors. So in taping, we have three main sources of error. We have instrumental errors, we have natural errors, and we have personal errors. So now also we are going to talk about other method of measuring distances. We have the electronic distance measurement, EDM. So the EDM first introduced in the 1950s, and it has undergone continual refinement since it has introduced. And the event of the EDM equipment has completely revolutionized all surveying procedures, resulting in a change of emphasis and techniques. So since the EDM has been invented, everything in surveying has completely changed. The procedure, the technique, everything. And the EDM, it measures the length by indirectly determining the number of full and partial waves of transmitted electromagnetic energy required in traveling between the two ends of a line. So if you have a line, then through the EDM, waves of electromagnetic energy is going to be transmitted, and then you are going to have reflector at the end reflecting this energy. Then in order to know the length, I need to know the number of the waves transmitted and the waves received, whether they are full or partial waves. So the process is indirectly we are gonna measure the length by measuring the full and the partial waves of the transmitted and received electromagnetic energy. In case you are going to use EDM, the distance can be measured easily, quickly, and with a great accuracy, regardless of the terrain conditions. Sometimes the terrain conditions could be very difficult. You are measuring through rivers or you are measuring through valley. So if you are going to use those traditional methods, it's going to be very difficult for you to get done with the measurement. And also the accuracy is going to be decreased. But using the EDM, the measurement is going to be easy, quickly, and the accuracy is going to be very high, whether the terrain condition is good or bad. So in order to use an EDM system, the instrument is set over one end of the line. So at one end of the line, assume this one is point A, this device is going to be fixed here exactly at point A. And at the other end, the point B, we are going to put some kind of reflector. So at point A, I'm going to install the EDM instrument, and at the point B, I'm going to install some kind of reflector. So this reflector is going to reflect the waves that has been transmitted from the EDM instrument. So this device is going to transmit electromagnetic waves, okay, and this one is going to reflect these waves again, and the device is going to receive the reflected waves. Okay, so I need to put the instrument at one end and the reflector at the other end, and then the electromagnet is going to be sent and then is going to be returned again. So how we are going to get the measurement? We are going to get the measurement. This device automatically is going to compare the transmitted and the received waves, and the instrument is going to be able to compute and display the required distance. To understand how this device is working, we need to understand how we can determine the length of the wave. The length of the wave here is going to be referred by the letter lambda. So lambda equals c over f. C represents the velocity of the wave, and f here represents the frequency in hertz, 1 cycle per second. So uh, knowing the velocity and knowing the frequency, we'll be able to determine the length of one wave, okay, in meters. Then the electromagnetic energy is going to be transmitted through waves. So that's why it's important to measure the length of the waves. Then it's going to be reflected again in the form of waves. Okay, so here through this formula here, we'll be able to measure the length of one wave. Okay, and the distance is going to be the distance from here to there. It's going to be referred by L or D. So this one is L or D. Here I have the waves that transmitted by the device. Okay, and here I have the waves that has been reflected by the reflector. I have these waves here and I have that waves here. I'm going to separate them. This one is going to be here and this one is going to be there. The distance here is D or L, and the distance here is also is D. So I can separate this one by putting the transmitted waves here and the received wave here. So this one plus that one is going to give me 2D, right? So I can say that the distance here plus the distance here is going to be the numbers of waves length plus a partial part of the wave length, because here I'm going to have complete wave, then complete wave, and so on. But the last one is not going to be completed. It's going to be partially wave length. Okay, so we can say that 2D equal n lambda. N is the number of the waves. Lambda is the length of one wave plus uh, plus the epsilon here. So I'm going to have this letter represent the partial wave length. Okay, so 2D equal n lambda plus this letter here. Okay, so the device using this formula will be able to determine the length by using this formula. And in this formula, I need to know the number of waves and the length of one wave and the partial wave length. So D is going to be, if you are going to solve for D is going to be n lambda plus this letter over 2. This letter represents the partial wave length. This is how this device works. Okay, so this is how this device works by using this formula. But for you, you are the final result is going to be displayed on the device. So finally, we talked about this method of measurements. We talked about pacing. We talked about taping, and finally, we discussed the electronic distance measurement (EDM). So we need to talk about the accuracy of this method. The accuracy of pacing is 1/100, which means that if you are going to use the pacing method, then you are going to produce an error of 1 meter in 100 meters. So if you are going to measure 100 meters, then you are going to have a mistake plus or minus 1 meter. Okay, that the expected error. If you are going to use taping, if you are going to measure 10,000 meters, then you are going to have an error of 1 meter. Okay, so this one is more accurate than that one. And if you are going to use electronic distance measurement, then the accuracy is going to be between 1 over 10,000 to 1 over 100,000, which means that you are going to produce an error of 1 meter in 10,000 or 100,000 meters. So the most accurate method is the electronic distance measurement. The uh, the uh, the method with the bad accuracy is a pacing. It's expected, and the taping is reasonable. Okay, so here we can see the accuracy for the different method that we have discussed. So it's the end of this lecture. If you have any questions about what we have discussed, please ask me.